Air travel is today the safest form of transport worldwide. However, safety can never be taken for granted. Constant effort is needed to maintain the highest safety level, taking into account the global air transport industry and its changing operational context. To this end, 13 organizations across Europe have joined forces to address future air transport constraints, such as changing flight conditions, emerging technologies, and more exposure to hazardous weather, in order to meet the needs for European-led research and development in fuel system safety. The key deliverables include a new fuel system design meeting the safety constraints of composite and more electric aircraft, innovative technologies for gauging, fuel circulation and inerting systems, and the necessary data to support authorities' rules and regulations for safe flight in icing conditions. The SAFUEL consortium meets regularly to discuss ongoing work and share preliminary results. We met them at their latest meeting and they explained the results of their work for you.
So the results we could achieve regarding icing are a better understanding of the phenomena, and we could observe ice accretion and ice release on pipes, which was not the case up to now. Regarding inerting, we have identified ways to reduce consumption of the system by 15%. That means 15% fuel consumption reduction, so more environment-friendly system. And regarding gouging, we have found some solutions. Some are, I would say, ready to use or will be ready to use in a near future. Some are more long-term solutions, but it's interesting to consider them from the beginning to have a long-term view of what are the technical solutions and what can be the evolutions of our systems.
The result seems promising. We was able to realize a prototype of this new fuel level sensor based on optical fiber. We have preliminary tested in Naples, and we successfully obtained very good results. So we are able to measure with very accuracy the fuel level. The sensor is insensitive to the ice, insensitive to the water, is able to work independently of the kind of the jet fuel that is used on the airplane, also for the new generation of airplane and the new generation of jet fuel. And another prototype now is under evaluation at NLR laboratories in Amsterdam.
Our research focus is to, what I mentioned, to characterize the sensors. So how will they behave in a simulated fuel environment to achieve the objectives of such a sensor in an aerospace fuel environment?
Well, we have been developing specific materials for this application, oxygen and temperature sensing in fuel tanks. And I cannot enter into the details, but we already have very encouraging results.
Results are in progress because now we are trying to prepare the accelerometer, the vibrators, to evaluate the response of in frequency and during test vibration of this new prototype that CNR is building. Okay. We are working together with CNR.
Up to now, we have built up a test facility with which we are able to show, to make it visible, the dynamic behavior of the ice formation and the release. So we can, for example, show movies, how the ice is attached to a small cylinder in a fuel-carrying pipe, and how it is really released if we change parameters. But we are still going on to investigate this phenomena because we all don't have understand all the mechanisms which leads to the formation, to the release of ice. But this is research we are carrying out.
The target to the end of the project is to make some conclusions and to use these results and to transform all this data we have today into innovation or into general conclusion that all the industry will use or may use in the future after the project.
For now, we have very good results concerning the validation of our software package. We validate the software based on numerical simulation using different other packages that are in the market and are validated already in the market. But for the future, for the next few months, we're expecting some experimental data from Zodiac and the use of our package by Zodiac mainly to validate their own experience and to reduce the number of tests during the experimental process.
We've shown that quite surprisingly our sensors are very sensitive to the very small quantities of water that you get in fuel, so they produce significant changes in the devices that we fabricate. So we also understand now very much better the process of water uptake in the fibres, so we can interpret the results. And hopefully, with the last phase being testing in a representative fuel system, we should have a system that's been proven to work in a realistic environment.
I think for us, when we came into the project, one of the key objectives to start with, and you can say result of sort, was to make sure we get a set of high-level objectives agreed and released out to the consortium, which has happened, I'm glad to say. And the second part of the focus is to look at the technologies. And one of the key items that will happen on Thursday is the TRL3 review for these technologies, mainly to do with gauging, and where we will have our senior reviewers come down from the UK, along with other senior reviewers from Zodiac, as well as EASA and SNECMA, to challenge these technologies. And I guess the proof will be in the pudding. If they get through the TL review, it's a success, or else there will be some more refinement to be done in the technology so that they can come back and pass the review. So that to me would be the key results for us.
Arctic was responsible for running the global organization of this group and coordinating all participants.
Arctic in SAFUEL supports the coordinator and the partners, the budgeting and reporting, and preparation for exploitation after the project ends.
SAFUEL is about working together and using our complementary strengths to advance the state-of-the-art of European industry. The participants present their experience working within this European consortium.
Well, so it's a quite long project, but very ambitious, very interesting. From the beginning, it was not so obvious that we could even have positive results, but this is the case, so we are quite happy with that and hope to collaborate again with Zodiac and Airbus guys in this kind of projects.
It's a very good experience of open innovation, I think. Having everybody around the table try to be a team to increase the safety of the aircraft is I think it's a very good experience in terms of, say, team spirit with multicultural aspects.
It's been a very good project to work with. The partners have been very helpful. It's been quite challenging because it's in a slightly different area that we normally work in, and it seems to be being quite successful. So it ticks all the boxes. It's been a good bit of work, I think.
It's a very good experience. You take your time to look for solutions within the future to have an even safer and a more innovative aircraft. And that's within the research institute the main objective.
Oh, I think really it's a great experience because we from a university get contact with people who are really working, producing fuel systems, and we can exchange this knowledge. And I think this is a great chance, and this is a great advantage of European project. We get contact to people from other countries, from other universities and from companies which are really building these systems. Therefore, for us from Hamburg University, this is a really great experience.
Thanks for watching. For more information, log on to our website www.safuel-fp7.eu.